Nice. So today we're going to look at kinematics. Once again, if you did physics, this might you might find this pretty comfortable, or you may not. So today's 12.6, Monday 12.7. Today I'll give you your practice test. Test is next Friday, and one more chapter after this. Okay, finishing really quickly. So here we've got three things that are happening. You've always got position, velocity, and acceleration. So position is basically the location. For example, if you're driving a car, where is your car compared to where you've started? Velocity, what's another name for velocity? Starts with S, speed. So speed, but in particular, it's with a direction. Okay, speed is just speed. But combine it with a direction, you've got velocity. And acceleration is depending how fast you are getting faster. Okay. Or how slow you're getting slower. For example, when you're accelerating, you might have you might be in the car who's doing who's learning to drive. Okay. Who's doing manual? Anyone doing manual? Zach? Okay, how's the bunny hops going?
Fine, not
Good.
too hard.
Not too hard, you got it. Okay, good. Anyone else doing manual? Any? Getting the clutch? Okay. Okay, not stalling too much. Now, just like in an auto car, you can actually press on acceleration and have a value for acceleration without going anywhere because you might just be neutral. Okay, so just something to think about in regards to acceleration. So over here, position is always, they always like to do this with an X. They usually start off with the position equation. And how do we get from an equation for position to an equation for velocity?
Time. Like you need the time.
We still need time, looking for something particular. Okay. All we need to do is simply derive our position equation. That's all we're doing. Okay, t cubed becomes
T squared.
3t squared and then minus 12t. Likewise, if you want to go from velocity to acceleration, we derive again. The way this looks like is dx squared, d squared x over dt squared. I know it's pretty weird, but that's the notation. Once again, 3t squared becomes 6t and minus 12. Okay, so we derive x, v, a. Just derive. When the question asks initial position, what's this going to tell us to do? Okay.
Where your x, or technically your y-axis, is equal to 0.
Great. And in the context of this, what value is 0?
0 centimeters.
Not quite.
Times 0.
Time is 0. Okay. Time is 0. I could, at time 0, my x might actually be 100 in front from the original spot. Okay. A good try again. So t is 0. All we need to do is substitute in. So my initial 0 cubed, 0 squared, we're left with 5. Initial velocity. Okay, what's initial velocity? It's 0. Initial acceleration, is it 0? It's not. If I substitute in my 0, I get it's a deceleration. This is centimeter per second squared unit. This is centimeter per second, and this is centimeters. Okay. Now I just want to explain the difference between these two things. If I have a question like this, that's the first question. This is the second question. Just going to put some definitions here before we move on. Velocity says it's the rate of change of the position of what's above over time. Okay? We're looking at this, looking how fast this is changing. When I go down to acceleration, it's a rate of change of velocity over time. This is saying how fast is this changing? You must get information from above at times. Now we've got two questions here. It can be really easy to get confused which one to do. Find the instantaneous velocity at 4 seconds. Okay. If I go here, it's pretty straightforward. I'm going to go to my velocity question, my velocity equation, and I'm just going to plug that in. Okay. So instantaneous velocity, 3t squared minus 12t, so 3 times 4 squared minus 12 times 4. If you put that in your calculator or do that in your head, can anyone tell me what you get? I heard it in my ear. Someone said it. You get 0. Okay. At 4 seconds, it's actually resting velocity. It's neither going anywhere. Now, this looks like a similar question, but the key, this is instantaneously. This is over the first 4 seconds. So what must we consider? Can anyone tell me what? I think I may or may not have explained what's the key thing when we do averages. Does anyone know? We'll do this question up here. If you want to find out average velocity, average velocity is a rate of change still, but it's change in position over change in time. Okay? So it might seem that it says velocity here. It might seem we might go into here. That's the mistake. Because we're looking at change in position. Okay. So what am I trying to say? Is the last one today. The change in position. What's the initial position?
5.
It's 5. 5 with a
0.
with a 0. But I want something in here now. What is it? I need a 4. But we're talking about position. So I've got to put it here. Okay. If you get that, you'll get, from haven't done a mistake, negative 27. Okay. Negative 27. So if I want to find in the change of position, I'm finding the difference. So the difference between negative 27 minus 5, or if you want 5 minus negative 27, what is this really?
Right.
It's gradient, rise on run. That's all it is. When you look at the word average, it's simply rise on run. What, without doing any minusing, what's our bottom number in this equation? It's a 4. 4 take away 0 is a 4. So we're left with 32 on 4, which equals 8. Or in velocity, 8 centimeters per second. Okay. Did I make a mistake there? Should it be positive or negative? I think that's right. Okay. Any I hope I haven't made a mistake in that. Do let me know. Negative. I think it should be negative, but I don't know where my mistake is, Miles. Where did I do it wrong? Yes, correct. I had it in the wrong order. I have to put the S first. Thank you very much. Okay. And that's, can you see how the difference, just because one is 4 seconds and one over 4 seconds does not mean that they're the same answer. Okay. What does that look like visually? I'm not going to put the graph up. If this was the X graph, instantaneous at 4 is our tangent. But an average is looking at this, we're looking at 0 and 4, and we're doing the gradient of that. See how you got different answers there? Tangent, and a line going through 2 dots over the span of the time that you're after. Okay. All right. That's predominantly what I want to share today. There's a few extra things in there that you can go through. Any questions? Okay.